Hey, hi everyone. Today we are going to solve one of the really interesting problem, maximum depth of a binary tree, or I would say maximum height of a binary tree. So basically what we have the root of a binary tree and we have to figure out the depth. And what is the depth? Depth is a number of nodes in the path from the root node to the farthest leaf node. So there is a root node and the farthest leaf node. So we have to figure out the number of nodes between that longest path. So for example, in this case, 325, 15 and 7. The root node is 3 and the farthest leaf nodes are 15, 7. So the number of nodes along these paths is a 3. So the depth of this particular tree is 3. Can you see this? Okay, so how can we solve this problem? Can we use ladder or something like this? Just think over it, pause the video. Cool. ठीक है. Well, we are going to solve this problem and we are going to understand how can we tackle this problem using recursion and all. ठीक है? चलो. Suppose this is a question, this is a tree, and in this case, the maximum depth is this is a first node, this is a second node, and these are the third nodes. So the maximum depth is equal to 3. Now let me copy this, or I would just draw a new diagram. We will understand how can we solve this problem. First of all, is a function definition clear to you? We have a function which takes the root node and we have to return the depth of that particular binary tree. So that is a function definition, or I would say function declaration. What is a function declaration? So depth is a function, get max depth. It is taking a root and it is returning the maximum height. So that is a function declaration. And next things is assumptions. We have to make some assumptions. Suppose here you have the maximum height of a left subtree and you have the maximum height of a right subtree. Can you use this? Suppose we have height of or depth of left and right subtree. Can we use this? First thing, suppose this is a I would say this is a root node. This is a left subtree. This is a right subtree. 4, 5, and this is a left subtree. This is a right subtree. Height of a left subtree is one, or depth of a left subtree is 1. Depth of a right subtree is a 2. And when we are at a root node, we have the depth of both the subtrees. Can we use this? Yes, definitely we can use this. What we can do to get the height of a whole tree, what we can do, we can just take a max depth, max of max of left subtree depth or right subtree depth, and we can just add 1 into it. Suppose this is a 1, 2, the maximum depth of any one of the subtree is 2, and we will add 1. So total depth of the tree will be 3. So that is an assumption. Now we will just dry run this problem. We will take a one more example. We will take a same example. Suppose this is a 1, this is 2, this is 3, this is 4, this is 5. Before that, I just wanted to clear if I just wanted to clarify the base case. If a root is null, if a root is null, there is a no node into the tree. What will be the maximum depth? It should be zero, right? So in this case, if root is null, then max depth should be zero. This is clear, right? Now we can just dry run this example. Okay, cool. So can I say for every leaf node there will be a two null childrens, something like that. So this will be a null, this will be a null again, null and null. So as per the base case, so this is black. We will start at the root node. We will start at the root node. We will go to the left subtree. We will come to the root node and we will go to the right subtree and then we will come to the root node. So we will use a post order traversal. So from the root, we will visit the left subtree first. We will get a maximum height of a left subtree. Then we will visit the right subtree. Then we will get a maximum height of a right subtree. And when we are at a root node, we will take a maximum height among the subtrees and we will add one. So I am at a root. I came on 2. From 2, I came on null. So it will return 0. It will return 0 because that is a base case. Again, I will come on the right subtree. It will return 0 again. Now at 2, we have a maximum depth of both the subtrees 0 plus 0. So the height or depth of a 2 is 1. Now we will return that height to the 1. Now we will come back to the 3. From 3 we will come back to 4. From 4 to null. Base case is here. Null. Again base case is here. Can we say height of a 4 is a 1? Then we will return 1. Again there is a 5. After we will that visit 5. We will visit null, then 0 as base case is there. Then again it is 0. Can we say both the subtrees are returning maximum height? So maximum height is 0 comma 0 plus 1. As per this formula, we have to use this formula at each node. After that, we will return from here we will return 1 as a maximum height of a right subtree of a 3. And now at a 3, maximum height of a left subtree and right subtree is 1 comma 1. So as per the formula, max of 1 comma 1 is a 1 plus 1 is equal to 2. So again here we will return 2, and at a max here, can we say max of left subtree height is 1 comma right subtree height 2 plus 1. In this case this will be a 2 plus 1. So the maximum height is 3. The whole maximum height of a tree is 3. So we can solve this problem using post order traversal. As you can see the question, we are getting the information from the children. So and after that we are using that information at a parent level. So this is the formula, and time complexity and space complexity would be, suppose this is a time complexity and space complexity. As we are visiting each node only once, so the time complexity will be O of n and space complexity will be O of n if a tree is cubed. So that's all. We have solved the question, and let's try to code this. So this is the question. Uh, First is we will add a base case. If a root is none, return 0. Then like a max left subtree depth Okay, left subtree depth equal to self dot max depth equal to root dot left, right subtree depth equal to self dot max depth. We will just call root dot right, and at last we will just take a maxim out of it. So left subtree max and right subtree max plus 1. So that's all. Let's try to run this. It should work. It should work. It is working fine. Let's try to submit this. Yeah, it is working fine. Cool. So this is all about this question. If you have any more doubts, please feel free to drop a comment on the video. Okay, chalo bye.